Have you ever stood in front of the Pantheon in Rome and wondered, how has this magnificent structure, with its massive, unsupported dome, stood for nearly 2,000 years? Or how have ancient Roman harbors and aqueducts survived centuries of waves and weather, while modern concrete can start to crumble in just a few decades? The answer lies in one of ancient engineering's greatest triumphs: Roman concrete. Welcome, history buffs and engineering enthusiasts. Today, we're embarking on a journey back in time to uncover the secrets of this incredible material. It's a story of volcanic ash, seawater, and ingenious chemistry that allowed the Romans to build an empire that would endure for centuries. Forget what you think you know about concrete, because the Roman version was a game changer, and its legacy is still teaching us lessons today. So, what exactly made Roman concrete so special? Unlike modern concrete, which is typically a mix of cement, water, sand, and gravel, the Romans had a secret ingredient. For many of their most durable structures, especially those near water, they used a special volcanic ash called pozzolana. This ash, found in abundance near Naples and Mount Vesuvius, was the key to their concrete's remarkable properties. When the Romans mixed this pozzolana with lime and water, it triggered a unique chemical reaction. This wasn't just a simple case of drying and hardening like modern Portland cement. Instead, the pozzolanic reaction formed an incredibly strong and stable crystalline structure. The calcium aluminum silicate hydrate binder it created was not only strong, but also remarkably resistant to chemical decay. This is why structures like the Colosseum and Roman aqueducts are still standing, showing us the sheer genius of their builders. But the story gets even more fascinating when we look at their maritime structures. How did Roman engineers manage to build massive piers and breakwaters directly in the sea? You might think pouring concrete into salt water would be a recipe for disaster, causing it to weaken and erode. For the Romans, it was the opposite. It was their superpower. They discovered that when their pozzolanic concrete mixture came into contact with seawater, it triggered a secondary reaction. The seawater would dissolve components of the volcanic ash, allowing new, interlocking crystals to grow over time. Specifically, a rare mineral called tobermorite would form within the concrete's matrix. This mineral made the concrete even stronger and more crack-resistant as it aged. Essentially, Roman seawalls healed themselves and became tougher over the centuries. Modern concrete, in contrast, is corroded by salt water, which attacks the steel rebar inside. The Romans built structures that thrived in the very environment that destroys ours. Let's pause and think about that for a second. An ancient building material that gets stronger with time and exposure to the elements. It's the holy grail of construction. This self-healing property is something modern scientists are desperately trying to replicate. Imagine buildings that could repair their own cracks, or bridges that become more robust with every passing year. The Romans were doing it 2 millennia ago. Another recent discovery has added another layer to this mystery. Researchers examining samples of Roman concrete found small, white chunks of lime, which were previously thought to be signs of poor mixing. But it turns out these lime clasts were intentional. When small cracks formed in the concrete and water seeped in, it would react with these lime clasts. The reaction would create a solution that recrystallized and filled the crack, effectively sealing it shut before it could grow larger. This was another brilliant built-in self-healing mechanism. This combination of pozzolanic reaction, seawater chemistry, and self-healing lime clasts created a trifecta of durability. It allowed the Romans to build on a scale and with a permanence that was previously unimaginable. Think of the aqueducts, stretching for miles across the landscape, reliably carrying water to bustling cities. These weren't just feats of engineering. They were lifelines of the empire, made possible by this superconcrete. The Pantheon in Rome is perhaps the most glorious testament to this material. Its dome, spanning over 142 feet, is still the world's largest unreinforced concrete dome. To achieve this, Roman engineers were not only masters of chemistry, but also of physics. They cleverly varied the composition of the concrete as they built upwards. At the base of the dome, they used a heavier aggregate like basalt for strength. As they moved towards the oculus, the opening at the top, they switched to lighter materials like porous volcanic rock and tufa. This reduced the overall weight and stress on the structure, ensuring its stability for millennia. It's a masterclass in material science and structural engineering, all achieved without computers or modern machinery. So, what can we learn from all this? The enduring legacy of Roman concrete isn't just in the ruins that dot the Mediterranean landscape, it's in the inspiration it provides for a more sustainable future. Modern concrete production is responsible for about 8% of global CO2 emissions. It's an energy-intensive process that relies on heating limestone to extremely high temperatures. Roman concrete, on the other hand, was produced at much lower temperatures, making it far more environmentally friendly. By studying its chemical composition and self-healing properties, researchers today are developing new, greener concretes that are not only more durable but also have a smaller carbon footprint. We are looking back to ancient wisdom to solve modern problems. The quest to fully replicate Roman concrete is ongoing. It's a complex recipe that varied based on location and available materials. But every new discovery brings us closer to understanding how this ancient civilization built a world designed to last. Their structures were not just functional, they were statements of power, ingenuity, and a deep understanding of the natural world. Next time you see an image of a Roman aqueduct or the Pantheon, don't just see an old ruin. See a marvel of chemical engineering, a testament to sustainable building, and a blueprint for the future. The Romans weren't just building for their own time, they were building for eternity. And in many ways, their legacy continues to shape our world, challenging us to build better, smarter, and more sustainably. Thank you so much for joining me on this deep dive into the secrets of Roman concrete. If you found this journey into ancient engineering as fascinating as I do, please hit that like button and subscribe for more explorations into the wonders of history and science. Don't forget to ring the notification bell so you won't miss our next adventure. Until next time, stay curious.